So what did you all think of the Google Glass Hangout this morning? What an amazing way to show off the power of real-time communication. And when I first heard about it, they're going to jump out of an airship and have it on a Hangout. I was like, that's pretty incredible. But anyway, I'm Justin Uberti, and today I'd like to tell you all about WebRTC, a project to bring real-time communication, RTC, to the open web platform. So I currently work on the WebRTC team here at Google, which is part of the Chrome project. Before joining WebRTC, I was the lead on the Google Talk team, where we built some really exciting applications and also learned a lot of really hard lessons about what it takes to do these kinds of apps in a browser. I also kind of learned that some people on the internet think I have really small hands. I don't get it. So enough about me. Let me see what kind of developers we have in the audience today. Raise your hand if you're really familiar with the following technologies. WebRTC? OK. HTML5? Good. WebSockets? App Engine? SIP? OK, OK. H323? OK, you folks who raise your hands, you have my condolences. So what exactly is WebRTC? Well, let me tell you a little story. A couple years ago, we were working on what would become Hangouts. The Chrome team approached us, and they said, the open web platform has some amazing technology, and people are building incredible apps with it, but there's one big gap remaining. To build apps like Google Video Chat, you need plugins, and these plugins have all sorts of problems, security, everything. What would it take to take the stuff you've built for Google Video Chat and Hangouts and make it part of the open web platform? Well, we said it would be really complicated. I mean, we'd have like all these technology issues to figure out, and we'd have to deal with like codec licensing and open sourcing, and most of all, we'd have to work with like other browser manufacturers and other industry players to make an actual standard for something that could be implemented across all browsers and across the entire web. And so, in typical Google fashion, the response we got back was, sounds like a plan. When can we have it? So we got to work. You know, where we didn't have the right technology pieces in-house, we went out and we acquired state-of-the-art, the very best technology out there. We assembled these pieces into a system. And as we started talking to other people, and we talked to other browser manufacturers, Firefox, Opera, Microsoft, we talked to people who would build apps on this platform, people like Skype, people like Cisco. And we talked to sort of the typical telecom providers, folks like Ericsson, AT&T. They were all super excited about this because of its potential, not just for the web, but for the entire communications industry. So that's the premise of WebRTC, to build real-time communications into the fabric of the web, where every browser has a built-in state-of-the-art communications stack, and create a new open platform that any application and any device can use to communicate. So think about that. This is where we're heading. The ability to get the communications industry, a $2 trillion industry, moving at web speed. Now, not only will developers be able to build and deploy voice and video apps just like any other web app, but we'll also start to see communication being built in as a feature to all sorts of apps. In a game, the ability to see the opponent's face right as you checkmate them. Or in a customer service on a website, a shopping website, to be able to talk to a customer service rep live in person with a single click. And as WebRTC takes hold across computers and all sorts of devices, we have the real ability to create the next generation phone network, where every WebRTC-enabled device can communicate with amazing audio and video quality. So take this quote from No Jitter. This is a communications industry blog. WebRTC in HTML5 could enable the same transformation for real time that the original browser did for information. That's a pretty lofty comparison. So how do we get there? Well, first, we need to get WebRTC in the hands of you, the developers. And here's where we're at with that. The first WebRTC support is now shipping in Chrome 21, the current Chrome dev track, and also in Opera 12. We're expecting to have Firefox join us before the end of the year. We've also brought WebRTC support to Internet Explorer via Chrome Frame. And so we'll soon have support across almost all desktop browsers. As this technology stabilizes, we're also going to see WebRTC start to appear in the various mobile browsers. And for those building native applications, we have native versions, either on desktop or mobile. We have native versions of the WebRTC stack that are fully compatible with their web counterparts. So the functionality the WebRTC offers falls into 3 categories. The first, MediaStreams, also known as getUserMedia, is about getting access to the user's camera and mic. There are a lot of cool apps that can be built with just this. Next is a technology called PeerConnection. This is the engine behind making high-quality, peer-to-peer voice and video calls on the web. Last is a new bit of functionality called data channels. It's so new, the spec for this hasn't even fully stabilized yet, but it has incredible potential. The ability for any web app to be a P2P app, to exchange application data peer-to-peer. Now let's take a look at each one of these. Now if you're following along at home, and you want to try out the things I'm about to show, and you're running Chrome, you want to turn on the flags to enable MediaStreams and PeerConnection. If you go to About Flags in your Chrome build, you'll see these options in the list. And you turn on MediaStream and PeerConnection. If you're in the dev channel on Chrome 21, you won't see a MediaStream option because it's now on by default. And if you don't want to turn these on for your existing version of Chrome, you can download Google Chrome Canary and run it side by side with your existing version of Chrome. So first up, MediaStreams. A media stream represents a media source and can contain multiple media tracks that can be of various types. So for example, if we get a media stream for the user's webcam and mic, we'll have a single stream, but a track for video and a track for audio, as shown in the diagram here. Now, in a video conference, we could have multiple media streams, and one media stream would exist for each participant, each one with an audio and video track. Now, once we have a media stream, we need a way to actually play it out. Now, fortunately, we have an easy way to play audio and video in HTML via the aptly named audio and video elements. Now, in order to plug a media stream into these elements, we first need a way to get a URL that references the media stream. Fortunately, there's a method called createObjectURL that does just that. Plug that URL into a tag, and the media will start to play. Now, lastly, how do we get the media stream for the webcam and mic? So there's a new API called getUserMedia. In Chrome, it's prefixed as WebKit getUserMedia, and the API is async. So you call it, it prompts the user for permission to access their devices. We spend a lot of time worrying about privacy and security, and that gives you back a media stream via a callback once it's successful. So here's that all put together. GetUserMedia, get a callback, create a URL, stuff it in a video tag. So let's see that in action. So here we get prompted for our camera. I'll pick my good camera right here. And there it is. Webcam access right in the browser. Pretty cool. So now let's jazz it up a little bit. So the first thing that everybody does with getUserMedia is to make a photo booth app. And we're not going to be any exception. So let's add a button so that we can draw the current video frame directly onto a canvas, just like a camera. So let's try that out. So here's our next sample. Get prompted. This time I'm going to tell it to remember it, so I don't need to do this again. OK, so give a big thumbs up for the camera here. And there's our photo booth. So of course, all good photo booths need some sort of video effects. The web platform gives us some great tools to do this. With CSS, we can apply a style to any visual element, like a video tag or a canvas. So here, we can apply a black and white effect, this built-in WebKit grayscale CSS. And so when the button is clicked, we're going to apply that CSS class to the video element. So I've made a demo, and I've got a couple more effects in here. So let me show them to you now. So start up, and since I've remembered the preference, it doesn't need to prompt me again. So let me try. We got sepia tone here, and let's see. There's blur, and there's black and white. And black and white looks real serious. So there's a lot of cool stuff you can do just with these things. Now, that's what you can do with a few lines of code. But I want to show you now a complete photo booth application that uses this technology. And the app I'm about to show you is called Webcam Toy. And it's written by a guy named Paul Neve, who got involved with WebRTC in the very, very beginning. And so this thing uses Canvas and WebGL pixel shaders to do some really amazing effects. There's over 100 effects in this app. So there's some really cool ones. Like, let me show you. This one's one of my favorites here. It's snow. It comes down, and it sort of builds up and stuff, and it's like you can kind of clear it off and stuff. It's really cool. And let's see, what else? The sketch one. This is also one of my favorites. But what I really want to do is, let me take a picture of this room so I can remember this moment here. Yeah, right. What's a good effect to use? I like this one. All right. Immortalized forever. OK, so one other thing that Paul has done, though, is he's wired getUserMedia to do real-time face recognition in JavaScript. So here we have real-time face detection running in JavaScript. Now, I never thought I would be saying those words, but here it is, as long as I look at the camera. So this kind of gives a new meaning to Chrome's incognito mode. So as you can see, some amazing things are possible when we combine WebRTC with the rest of the web platform. OK, so that's how we get access to devices. Now, PeerConnection will let us take those media streams and send them across the internet peer-to-peer. So PeerConnection, as its name indicates, is the API they use to set up peer-to-peer sessions. And it handles all the tricky parts you need to establish a connection and run audio-video over it. Establishing the P2P link, managing the various audio and video codecs, encryption, tuning the audio-video stream to make best use of the available bandwidth. But before we get into how PeerConnection works, let's take a look at a typical voice-video application, like how Google Talk would set up a call. So the app wants to be able to send the media directly to the other side. But in order to do so, it needs to establish the direct link and the details of how the media should be sent. And the way it does that is sort of by rendezvousing through the cloud, by sending signaling messages over its connection using a protocol like XMPP or SIP. And these messages are relayed to the other side. This exchange of parameters allows both sides to successfully rendezvous and establish the call. Now, we could have just taken that logic and stuffed it into the browser. The app would just tell the browser where to connect to, and it would establish a SIP or XMPP connection, just like a desktop app. But this doesn't really make sense for a couple of reasons. The app already has a connection to the cloud using HTTP. And if we bake the signaling protocol into the browser, we'd have to pick one that everybody could agree on. That doesn't really seem too likely given the various apps that are out there. And lastly, this connection would have to deal with all the proxy and firewall issues that HTTP has already solved. So we didn't do this. What did we do? So we have an approach that's called JSEP, JavaScript Session Establishment Protocol. And we thought, let's put the minimum we need into the browser. In 2012, that's peer-to-peer networking, codecs, and encryption, and let the app do all the rest. The app can manage all the call setup using whatever mechanism it wants. The app will simply tell the browser about the parameters it wants to use for the call using things we call session descriptions. As long as the app has some way to exchange session descriptions with the other side, it can do this any way that it wants to. So for example, we could use App Engine and use XML HTTP requests to post the session descriptions using in a JSON encoding to App Engine and have App Engine deliver them to the remote side using the App Engine Channel API. Or we could actually implement the SIP protocol in JavaScript, convert the session descriptions to SIP messages, and send them to existing SIP equipment out there. And so there's a ton of existing SIP equipment, the phone network, soft switches, existing enterprise video conferencing equipment. And people are already using this today to have SIP interop with WebRTC without forcing WebRTC to have SIP built in. So the abstract PeerConnection API allows us to handle either of these cases, along with a whole set of others that I haven't mentioned. Now, the basic thing that a PeerConnection needs is a local session description, which holds the local parameters for the call, and the remote session description, which indicates the remote parameters. It also needs the transport candidates, which are the IP addresses and ports the remote side is reachable at. Sometimes these are included within the session description. Now, I'm going to walk through a call setup and show how these parameters are exchanged. One thing to note, the initial parameters sent by the caller specify everything that the caller is capable of, and we call that an offer. The response from the callee, which indicates the negotiated or selected parameters, is called an answer. So here's the first thing. The app creates the local session description, the offer, passes it into the PeerConnection API, and sends it to the remote side using whatever mechanism it wants. The caller gets it and gives it to the PeerConnection API as the remote description. Then, assuming that the callee accepts the call, generates their own session description, passes it into PeerConnection, and sends it back to the caller as an answer. The caller gets that answer and gives it to PeerConnection as a received session description. Now at this point, the browser has everything it needs to establish the call. The local session description, the remote session description, the transport candidates, the P2P link gets established, and media flows. So let's look at what this looks like in code. The caller creates a PeerConnection, plugs a media stream into it, which it got from the getUserMedia API via add stream. It then creates an offer, plugs it in, and sends it off to the callee. When the callee gets it over here on the right, it creates a PeerConnection, stuffs in the offer via set remote description, and then creates its own session description as an answer that it can send back to the caller. The caller then gets this answer on the left, calls set remote description with the received answer, and the setup is complete. So let's see how this looks like in code. We're going to do the offer answer dance here in a single web page with two PeerConnections. Instead of sending these messages across the internet, we're going to just stuff them directly into the appropriate PeerConnection. So let's try this out. I still like this incognito mode. OK, so we start up the camera. And now when we hit the call button, we're going to spin up all the codec, P2P, crypto, all that sort of stuff, and we should see the video appear in the panel on the right as what the remote user would see. Bang, there it is. And let me show you that again. You can hang it up and call again. And there it goes. So you can see that we have this functionality, and as long as we can send these session descriptions back and forth, the rest of it pretty much manages itself. Now, that's kind of cheating. Passing the data back and forth within a single web page isn't really that interesting from a video call scenario. We want to call someone on the other side of the planet, not in the same web page. So how are we going to do this? Well, in order to make this into a real video calling app, we need to send those session descriptions across the internet. Now, let's look at how we can do that. So it's really easy to send a session description to the cloud. We just make it into a string and shoot it off over XML HTTP request. But how can we receive them? Especially, this is a real-time application. The caller doesn't want to sit there forever waiting for the callee. We don't want to spend a lot of time polling. What can we do? Well, App Engine gives us a great tool for this. The Channel API provides an easy-to-use server-to-client signaling path for pushing session descriptions from the server to the client. And App Engine takes care of all the details. No matter how many users you have or where your users are in the world, you can use the same simple API to send down messages. So here's how it works. First thing you do, establish a channel. You can do this when serving the web page to eliminate a round trip. So in the server, you simply create a Channel API token and send it down in the web page response. The app then uses the JavaScript API with that token to bring up the back channel, and you're ready to rock. You can send messages from your server down to your client. So here we have client B that wants to send a message like a session description to client A. It does so typically with a post or using XML HTTP request to get the message up to App Engine. And that includes an identifier to indicate who it should be sent to. Now, your app can use that identifier to find the right channel instance on the server side. And once it does that, you simply call send on the channel, and it gets pushed down to client A, who receives it in a JavaScript callback. Super easy. So here's a snippet that shows how this all works. At the top, the client brings up the back channel using the App Engine API. Then, when it gets an incoming call message in its callback, we can set the remote and local descriptions, create an answer, and then shoot that back using XHR. So these are some great little examples to sort of show the basics of the API. But we also want to have a complete video calling application, a reference sample application, where we can show developers the best ways to bring this stuff all together. And we also want it to be a kind of application that we can use in our daily work, not just a sample app, something that would be a full-fledged reference application. So we created WebRTC. It runs an App Engine using things like Channel API and Data Store, and shows how to use the WebRTC APIs, handling session descriptions, making call setup fast, ensuring NAT traversal works, and every WebRTC call is fully encrypted. Now, I really want to show this to you. So we've got some people on the team, and they've been working really hard on some updates to WebRTC. Now, I want to just sort of check in with them real quick and make sure that they're not getting too stressed out. So let's do that now. Okay. Hey, Ray, you look pretty relaxed there. Did you get that work done I wanted you to do?
Yep, sure did. WebRTC and App Engine took care of the most complicated stuff, so I'm done, Justin.
Well, I mean, let me say, it looks great. I mean, not just the app, but I mean, also your pool. I wish I could swing by later. Anyway, I got to get back to the session. It's going great, and I'll let you get back to relaxing. Catch you later, Ray.
Right. See you, Justin.
So that's the kind of quality that you can accomplish with WebRTC. Real calls across the internet right from your web browser. OK, so we just showed how to send audio and video peer-to-peer. But what if we just want to send data? Well, enter data channels. So data channels are designed to allow apps to exchange arbitrary application data with low latency, high throughput and message rate, and optionally, unreliable semantics, so you can keep chugging even if you lose a packet. Now, there are lots of great real-world use cases that data channels are great for. If you have a game and you want to send the positions of bullets in a game, you don't have to send that data over HTTP, so server and back with all the HTTP overhead. You can instead send it in a very tight, efficient message over the peer-to-peer channel. For remote desktop apps, you can do things like track the position of the mouse with great responsiveness. And there's a lot of other great examples, but one I particularly like is the ability to create a secure, decentralized network. And you can imagine, in a place where there's censorship of the internet, you can provide this mechanism as a way where people could communicate over a private, encrypted channel. So here are the key features of the data channel. To set it up, we're going to leverage the PeerConnection setup. You do this sort of offer-answer dance. We'll get the channel bootstrapped. But then you can create multiple channels, and those channels can all be either reliable or unreliable. In a game, you might want your state updates to be reliable, but projectiles can be sent over an unreliable channel. Security and congestion control is built right in. The app gets this for free. And we've tried to make developers' lives easier by keeping a similar API to WebSockets, so that code written to use a WebSocket should work just as well when coupled with a data channel. So here's a simple usage of data channels. We want to have two clients exchanging data. They exchange session descriptions to get the peer-to-peer link set up, and then we're ready to go. We send the data, and it gets sent over the internet using standard IETF protocols, SCTP, datagram TLS over UDP. It goes through NATs. It just works. This is going to be a revolutionary technology. And here's what this looks like in code. It's really simple. You just call on each side, create data channel. You specify an identifier. This identifier is what allows both channels to get connected together in the middle, because they're indicated by name. And then once it's connected, you just call send on one side, and on message gets called on the other side, just like WebSockets. Now, I wish I could show this to you now, but as I mentioned before, we're still finishing up the details of the spec, but expect to see this in Chrome in the near future. So you can also imagine some more complicated topologies for this. If we want to distribute data between multiple peers, we can create a mesh where each endpoint is connected to each other endpoint. If you're creating like a multiplayer game, this is a really easy way to get multiplayer functionality without having to have a big server infrastructure. But you can also imagine some really other interesting things. You create a graph. And say you want to be able to sort of send down a lot of data from your service. Instead of having to send the data n times by unicasting it to all your clients, you can instead construct a tree and use peer-to-peer to push the data very efficiently to all your clients. Since you control the application, you can have the application take the data and it's distributed to other peers that it might be connected to. There will be some amazing things that will be created as a result of this technology. OK, so we went over a lot of stuff really quickly. Let's review. We're building real-time communication into the fabric of the web, providing amazing new voice, video, and peer-to-peer functionality in the open web platform, and enabling the communications industry to move at web speed. This is a really exciting time. We're really excited on the team. We can't wait to see the apps you guys are going to build on this. So MediaStreams are shipping in Chrome 21. PeerConnection is in Chrome 20 behind a flag, but we're working hard to try to stabilize it in time for Chrome 22. The data channel work is going to follow on after that, and we expect to do this by the end of the year. Now, Opera is also shipping MediaStreams now, and our friends at Mozilla, they tell us they think that they can get all this stuff done by the end of the year. Now, for people using Internet Explorer, we've got WebRTC running in Chrome Frame, and it works great. As we start to stabilize things, we're also going to see stuff landing in mobile browsers. And as I mentioned before, we have native versions of the entire stack available for the app builders out there. So here's our resident Icelandic team member, Tommy Gunnarsson. He's showing off AppRTC running here in IE, courtesy of Chrome Frame. So for more information about Chrome Frame, you can check it out at google.com/ChromeFrame. Now, incidentally, we might be thinking, well, what is Microsoft doing about supporting this natively in IE? Well, I don't know for sure, but I saw a couple WebRTC-related job postings show up on the Microsoft careers site in the past week. So I'm pretty sure they're investing pretty heavily in this. OK. So I'd like to show you one more demo, or two more demos here, of examples of what third-party developers are doing with this technology. So the first is an application called TwinSee. The team there has created a WebRTC app that works on both web and on mobile. And I'm going to call them up now using the app that they've built.
Hello?
Hey, guys. You're live at Google I/O 2012.
Wow.
So tell me about this app that you've built.
Okay, so let me introduce ourselves. So I'm Michel Gian, and I'm here with Christian Jacquemot, and we founded TwinLife at the beginning of this year. And the purpose of TwinLife is connecting generations. So our focus right now is to take Android tablets and smart TVs and make them usable by older persons so they can interact with their family, their children and grandchildren. So our first building block is this TwinSee service, which is made of an Android application using the native WebRTC APIs, which Christian integrated into Android, and a web service, TwinSee.net.
Thanks, Apple.
To connect users, whether they come from a Chrome browser or whether they come from a TwinSee application on Android tablet.
That's great. It feels like you guys are like right here in San Francisco with us. So when can I expect this to be available?
TwinSee will be available in the, for public testing on the Android market in the August timeframe. So I'll show you here in the mirror. You can see that this tablet we're using right now, this Asus Prime. And so if you have any question, contact us at TwinSee.net.
OK, that looks great, guys.
I hope you're having fun in Google I/O. I wish we were there.
Looks great, guys. Well, that's really exciting. I'll let you guys get some sleep. Talk to you later.
Sure.
OK, so the last thing I want to show, I know a ton of you are using GitHub to host and share your code. So that's why I'm really excited to introduce this next app called GitTogether, which brings real-time communication to the GitHub community. Now, the guys who built this have been involved with WebRTC since the very beginning. Let's call them up now, and they can tell you about how this works. These guys have been working on this. They're creating not just an application, but also a JavaScript framework that allows a lot of simplifications to be done for people who are WebRTC developers. So that's everything for WebRTC today. We covered a lot of stuff quickly, but thank you. Also, the get-together made by vline.com. Also, check out the Chrome Developer Sandbox. We've got some stuff down there. There's Voxio, who is an emergency response app being built using WebRTC. And we've also got a really cool WebRTC-based game called Who Am I? Thank you all for coming. I'm happy to answer any questions that you might have. You step up to the microphone so the video can record it.
In a lot of your slides, you had a dotted line between the two browsers on the bottom. Is that a actual connection somehow? That, I mean, if both of them are behind a NAT firewall, how do you get the peer-to-peer communication to go? Is there actually a server there that's involved?
There's a technology called ICE. And ICE is Interactive Connectivity Establishment. And what it does is it basically finds all the IP addresses that it can come up with. Your local address, the address of your NAT or firewall, or an address that could be hosted in a data center. And it does interactive checks to figure out what is the best path between the two peers to establish data. In our experience with Google Talk, we find that in like about 90% of the cases, we can actually establish a peer-to-peer link even if both sides are behind NAT. You know, the sort of rules of NAT are such that we can establish, if we know the address of the other person's NAT, we can still get that peer-to-peer link going between two peers using UDP.
Thanks.
Hi, can you talk about codec support? Because I know you guys acquired JIPs, and with that came ILBC and ISAC, but are you going to do something like Opus support or something like that?
So this is all a big topic for the IETF, but what we are planning to support, assuming we can work out all the licensing details, VP8 will be our open, royalty-free video codec, and then as far as audio codecs are concerned, we'll support G711 for legacy interoperability. We'll support ISAC, and we hope to support Opus, assuming that we can, Microsoft can help us out on the licensing front.
And can you talk about ILBC voice quality on an Android platform? Have you guys had good luck with it? Does it, I mean, are you seeing good performance relative to a general cell phone call?
We have the person who wrote ILBC here sitting in the audience.
That guy right there?
Yeah, that
okay,
guy.
I'll talk to him. Thank you.
Hi. Simple question. I saw on the first demo that you showed how to use video and, well, you didn't show about audio, but I guess audio is also included. Only on one-to-one conversation. Is there a way to make it broadcast? For example, this show can be seen on a web page by multiple users?
Yeah, so there's a peer connection creates a connection between yourself and a remote peer. And if you want to have a multi-way conversation, there's a couple ways you can do this. The first thing is you could have multiple peer connections and establish a full mesh, like a show here. You know, if you have 4 participants, you establish 3 peer connections, 1 to each remote participant. This doesn't scale all the way up, so one of the other things that you can do as you get to be in large conference is actually have a central server and create like a star topology, where the other side, instead of being a browser, is actually a server. And then using like the WebRTC tools, you can create a server that could do multi-party.
Okay, I think maybe I asked wrongly. I'm only interested in one party who is transmitting. The other ones don't need to talk, only to listen.
Oh,
so
I see.
It's like UDP in that sense. Yeah.
Right. So, sorry, in that case, like the other side wouldn't even have to call getUserMedia. So the side who calls getUserMedia can specify whether it wants video and or audio, but you don't need to call getUserMedia at all. So if you want to receive only, you just would not call getUserMedia, and you wouldn't call addStream on that side, and then you would just play.
I see. Okay, thank you.
Sure.
So if you want to stream to the server and save the recorded video, are there server components or libraries that are available?
So I mean, if you're familiar with sort of media processing, you can build these kind of servers using the WebRTC components. There is something in the WebRTC spec for an API called Media Recorder. It's missing a lot of detail right now, so it's not being implemented, but we expect at some point in time there will be an easy way to do media recording. For right now, the easiest way is to build a server, make a peer connection to it, and then you can then sort of save it out to a file there.
So the component would be the C++ libraries that you would bind into your server?
Yes.
I had a question about whether screen sharing is still in consideration as a video source.
It absolutely is.
Yeah. Okay. Is there? Yeah.
The question is whether screen sharing will be supported as a video source. And it's sort of one of these things where we definitely want to support it. We have the technology to do it. But in terms of like making sure we get something out there, V1 will be just video only. You could also do it with camera drivers, although the issue with camera drivers is that their resolution will be artificially limited.
Do you have plans to integrate with server-sent events?
Server-sent events. You be specific about what you have in mind there?
Well, to get the session exchange pushback, the answer.
I think I'll have to get back to you on that. I'm not sure I'm familiar enough with the server-side events, server-sent events.
They're part of the WAT working group
Okay.
specifications. Okay.
We can talk afterwards.
Hi. There will be any SIP integration in the future? Any way to make a phone call using this API?
Yeah, so we actually have some demos, I didn't show them today, where you can actually make a phone call to the PSTN. And the way you do that is by, there's a couple ways you can do it. You can send JSON to your web server, have the web server then, gateway that to SIP. Or there's a project called SIPML5, SIPML5.org, where they're actually implementing a SIP stack within the browser itself. So you converts the session descriptions to SIP messages right inside the web application. So you can definitely do SIP calls, using this technology.
Great. And there will be an SDK for Android or something?
Yeah, we have existing SDK for. If you go to WebRTC.org, you can download, the code for running this on Android.
Thank you very much.
Sure. Okay. Thank you all for coming.